Hey everybody, Bill Sky, the FORTRAN guy, and today we're going to talk about subroutines. Now, what is a subroutine? A subroutine is basically the same as a function, except with a subroutine you use the call statement in FORTRAN instead of just issuing the actual name of the function, or the subroutine in this case. And there's also one other important difference, is that a subroutine doesn't return anything. So what you need to do is you need to supply the subroutine with a variable in the argument list that will actually contain whatever return value or values. Now there is one benefit to this, and the benefit is that you can return multiple pieces of data to a subroutine by including those variables inside of the variable list when you call the subroutine, instead of just returning one like a function does. Now there are ways around that. You can do the same thing in a function by making the function pass arguments by reference, and that's basically what a subroutine does by default. Now, why the difference? Because subroutines were around long before functions were. I believe subroutines were around even before FORTRAN 77, or FORTRAN 4, I should say, which is the version of FORTRAN I learned way back in 1976. So subroutines are something that are out there. There's a lot of code out there with them. Because how long they've been around. And so if you really want to learn everything about FORTRAN, this is one of the things that you need to learn as well, because you're going to be looking at legacy code if you get a job doing it. Now the other thing about subroutines is that they're very easy, because if you've already looked at my FORTRAN functions video, this is going to be really easy for you. And then after this, we're going to be talking about calling functions from external object files and things like that, as well as calling C functions and calling FORTRAN functions from C. So there's a lot of function videos in this series. So let's get on with it. Let's do it right now. Let's jump into subroutines in FORTRAN. Okay, so today I've got my Red Hat Linux running, and I just like to use different versions of Linux. I like to learn the different versions. You can take a look at I just have a few videos on Linux right now, but I'm going to be doing more. And what I'm going to do is I'm going to do a FORTRAN project, and we're going to do the Linux Intel. So I'm going to use that template. I'm going to rename it to something like Intel Subroutines, just to keep track that that's the Intel compiler that I'm using, the Intel FORTRAN compiler. And there's my FORTRAN program. Now, because we're going to be sending arguments and stuff, I'm going to create some variables. And this is kind of a normal thing you do when you're learning stuff. So I'm just going to create some integer variables. I'm also going to create a parameter. Now, if you don't know what a parameter is, take a look at my creating variables and constants video. But a parameter is basically a constant where you can't change it. So I'm going to call this one string length. I'm going to say equal to 0. Now why am I creating this parameter? Because now I'm going to create a string called the string, and it's going to have a length of string length, which in this case is 80. Now the benefit of this constant, this parameter, is that it allows me to change it just in this location, and then it'll change everywhere in my program where I use string length. So very important thing. Now the first thing I want to do is I want to actually create a subroutine. It's going to be much like the function that we did in the functions video, and it's going to be a very simple function or subroutine. It's just going to be print hello. That's what we're going to call it. So before I do that, I'm going to go ahead and actually call it. So you call a subroutine by saying call, and you just simply say print hello. Just like that. Okay? Now, let's go in here. I'm going to put a stop there. All of your programs should have a stop. And I'm just going to now say contains. Now, contains is the section of your function program which contains the subroutines, just like it contains functions. So in this case, I'm going to say non-recursive, and we'll talk about that in just a moment, impure subroutine print hello. And then down here, I'm going to say return, and then below that, and I'm going to indent that, and below that, I'm going to say end subroutine print hello. All right, now let's talk about some of these things that we've got here. So this is saying that this is a non-recursive subroutine, which means the subroutine is not allowed to call itself. So if I put call print hello inside of this subroutine, the compiler wouldn't allow it. And I love that, because it forces me not to do something that doesn't have a base case and doesn't get me out of the function and could be possibly an infinite loop on a recursive call. Impure means that the function will change the system. It will change the operation of the program, so it'll have like a print in it or things like that, and we'll talk more about that. We talked about that in the functions, but we'll talk even more about it. Then we specify the word subroutine, and then we specify the name of the subroutine and the open and close parentheses, just like we did in functions. And in this case, the open and close parentheses that are empty means that there's no arguments. Okay, so all I'm going to do is say print hello from, let's do this right. Hello from print hello. Okay, and that's our first subroutine. So we called it, and then we actually created it. So let's go ahead and get our compiler all ready. And I believe source opt intel one API set vars.sh. Again, you only have to do that once. I'm going to make it, and we have a problem. Oh, I have a semicolon here instead of a comma. So let's fix that. And let's run it. All right, there we go. Hello from print hello. Pretty easy little subroutine. All right, let's create another subroutine, and what we're going to call this one is I'm going to call this one mult by 2. Well, actually, before we do that, let's get rid of this impure, and let's make it a pure function or pure subroutine, just so you can see what happens. Let's make it, and we get an error. And the reason why we get an error is because pure functions are not allowed, or pure subroutines are not allowed to modify the system. They're not allowed to do things that are going to modify the operation of the program, and a print does that, basically. It's basically outputting stuff to the console. So print is not allowed on a pure subroutine. So that's why we say impure. I believe impure is the default. So if we leave out impure or pure, let's see what happens. It makes just fine. So I like to be very verbose in my code, so there's no question as to what it is or what the subroutine is going to do. So I always like to put in there that I know this is a non-recursive impure subroutine. Now let me do this. I'm going to say call print hello, and it's non-recursive. Let's see what the compiler does here. And we get an error. I'm not allowed to call the same function from within that function because I have listed here non-recursive. So again, just an example of what you can do. Okay, let's create another subroutine, and this one is going to be the same thing. And this one we're going to call mult by 2. And I'm going to use x and y. Now those are horrible variable names, but you know, we're just learning. So, and let's go ahead and return. And then let's say end subroutine mult by 2. And I've got an open parenthesis there, so my parentheses are a little bit screwed up. Okay, let's save and build this, make sure everything's cool. And we didn't actually do anything. We didn't actually define this subroutine well enough. So we have variables x and y that are being sent to this subroutine, so we have to specify what type of data they are. And let me see. Oh, I typed that in wrong. So mult, yeah. This is why I absolutely love compiling quite often, so I can find these little errors. All right, great. Okay, so now we're there. Now, I want to multiply x by 2, but how do I return it? Well, I'm going to return it via y, because the default when you call a subroutine in FORTRAN is it sends it by reference, which means you're not sending a copy of the data, you're actually sending the real data. So the actual address, it's not a pointer, but in a way it is. So what we're going to do is I'm just going to say here's y equals x times 2. Okay, now let's call that function up here. I'm going to say call mult by 2, and I'm going to say, let's just multiply 2. Actually, let's go up and use a variable. So we're going to use an integer. So let's say, let's do this. Let's say x equals 100, and we're going to say x comma y. So y will contain the result, and I'm going to say print y multiplied, oh no, it should be x, sorry about that, x multiplied by 2 is, and let's put y there. Okay, let me jump down to that function or that subroutine definition, and so you can all see it right there. All right, let's go ahead and make this. And we've got an error. Oh, forgot a comma. And let's run it. All right, pretty cool. So 100 multiplied by 2 is 200. Let's do another one. Let's do a function where that takes 3 arguments and has a little bit more fun in it. It's going to have a little loop in it. And let's call this one non-recursive. Let's call this one power by. It's going to take x, y, and it's going to return z. So what this function is going to do, it's going to take x, it's going to raise it to the power of y, and then it's going to return that value in z. So we're going to go ahead and say integer. We have to define those variables. So integer. And now I'm going to do something a little bit different here. I'm going to use this thing called intent. So what I'm doing is I'm saying that I want certain variables that are sent to this function to be non-modifiable. I don't want to be able to modify them. So the intent input for this integer is going to be x and y. Now what does that mean? Again, that means that x and y are only input to the function. I can't modify them. It's almost like in C or C++ I put a const in there. And this means that the intention of those two variables, x and y, are input only. And then I'm going to say integer intent out is z. So z is intentionally meant as writable. Now, that's default, so I don't really need that. But if you remember what I said a little bit earlier, I love to be verbose in my coding so everybody knows exactly what I meant to do. And I mean z to be output, and I mean x and y to be input. Now let's go ahead and put that in there, right? Okay, let's go ahead and now say return, and then say end subroutine power by. All right, let's save and build that. Okay, let me see what it says here. Oh, I haven't actually given z a value. So because I said z is out, I haven't actually given it a value. So what I could do is I could just say z equals 0, and that compile error should go away, which it did. Okay, so by saying out, it forces you to give it a value. It forces you to assign it some value because you're telling the compiler that that is really the output of this function. And I could do that with multiple variables. If I wanted to, I could put an a here, and then I could say z and a. And if I don't give a value, I should get the same error, which I do. So I'm going to say a equals 0. And you can see the problem goes away. So again, if you specify out, it's going to require you to actually give that argument a value. In this case, we're just going to say z equals 0. Okay. So let's go ahead and create a local variable, because as I'm calculating, now I'm not going to use any mathematical functions, which is kind of stupid because there's a lot of mathematical functions within FORTRAN, which is one of the reasons you use it. It's got very, very highly efficient functions, but I want to code here. So I'm going to create another integer, and I'm not going to give it an intent because it's going to be local only, and I'm going to call this one the power. Okay, and that is going to be my calculated value. That's going to be the calculated value of my raising x to the power of y. So I'm going to initialize the power, and let's go ahead and make this lowercase here. So I'm going to the power is equal to x. So we're going to move x into the power so we can begin calculating it. And I'm going to create a little do loop. Do z equals 2 to y. And I'm going to say the power equals the power times x. Okay? I'm going to put my in do. And I'm going to say z equals the power. And now I don't need this z equals 0. All right, let's save and build that. Make sure I haven't done anything silly, which I have. And that's because I forgot to take that a out of there. All right, works. Now let's go ahead and call the function. So let's say call, let's set some values. So let's say x equals 100. Let's say y equals 4. And I'm going to say call power by x, y, z. I'm going to say print x raised to the power of y is z. Let's make our program. Looks good. Let's run it. And here we go. So 100 raised to the power of 4. So we should have 2 more zeros, 2 more zeros, and 2 more zeros. There we go. Let's do this. Let's do something a little bit easier. I'm going to say x equals 2 to the 4. Let's make sure it works. I'm trying different values out here to make sure that my function is working. Okay, 2 raised to the power of 4 is 16. Is that right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Let's do this. Let's say 2. I don't know if I've got that routine right. It's not sitting right with me. Okay, 2 raised to the power of 2 is 4. Okay, let's say 2 raised to the power of 3. That should be 8. I'm testing my code. It is. Okay, so it looks good. So it looks like my subroutine is working well. Okay, so let me show you that subroutine one more time here. And you can pause and look at that code if you'd like. Okay, let's send a subroutine a string. And what we're going to do is we're going to convert that string into uppercase. Now we did this in the functions, but this is going to be a subroutine, so we're going to do it, it's going to be a little bit different. And so I'm going to go ahead and say subroutine to upper the string, the length, and I'm going to say n subroutine to upper. And we really need a return in here. I don't really think you need the return in there, but I always like to put it in there. Okay, so now we have to define those two variables. Now, I believe this function or this subroutine can be recursive. I don't want it to be, so I'm going to say non-recursive. All right, and let's go ahead and save and make it just so we know. Okay, what if, oh, we haven't defined those variables yet. Okay, so let's go ahead and define them. So integer, the length. Now what I might want to do here, I might want to say integer, comma, intent, input only. I only want that to be input, okay? And then I'm going to say character, the length. So I'm going to define the string as a character string of length of the length, and I'm going to say the string. Okay. Now what I want to do is I want to create a return string, and you're going to see what I'm doing here. So I'm going to say character, and what I'm going to do here is I'm going to say the length is undefined or undetermined. It's allocatable, which basically means that I'm creating a pointer called return string. So this is saying give me a non-defined length. That's what the len equals colon means. And I want this variable to be allocatable, so it's basically a pointer called return string. Okay, I'm going to create an integer here that's going to be used inside of the function only. I is just going to be my counter. Okay. Now there's a couple of things I can do here. Why am I making this an allocatable string? Well, first of all, or allocatable pointer. Well, first of all, just practice, right? You're learning new things as we're doing this. So what I could do things like this. I could say if the length is not equal to 0, then I can go ahead and do my allocation. So I can have some validation inside the function. We're not going to do that right now, but that's something that you can do. So what I'm going to do is I'm going to say allocate character length equals the length. So I'm going to allocate my string, my return string, called return string. Okay. Now, the reason why you might want to do some if statements, you might want to say if the length is not greater than, is it NGT? I can't remember. So if it's greater than 0, then I want to allocate it. So if for some reason you send that subroutine a negative length, you don't want to allocate a negative long string, do you? No. So that's what I'm talking about here, is creating some validation in your function to make sure, protect the programmer from themselves if they do something strange, right? But we're not going to do that here, but you can definitely do that. Okay, so we're going to allocate it. Now let's go ahead and make this and make sure I don't have any strange, inteng, that should be intent. Again, another reason I love doing short little compiles. All right, great. So we've allocated it. So now let's go ahead and let's actually convert everything to uppercase. So I'm going to say do I equals 1, because in FORTRAN, arrays start at 1, not 0. The length, and we're going to go by 1. I'm going to put the end do right here so I don't forget to do it. Excuse the pun. Let's go ahead and make it and make sure that everything looks good. Okay, so I've got my loop ready. So now I'm going to say if the string at position I to I, which would be 1 to 1, so I'm going to look at a single character, if it's greater than or equal to A, and the string of I through I, so that one character, is less than or equal to Z, then I want to convert something. So I'm going to say the return string at position I to I is equal to convert, and you're going to see what that char means. I want to convert the character at the string I to I want to convert it to an integer, so integer character value of the string at I to I minus 32. So what this is going to do is it's going to take the character at the string I to I, which in the first iteration would be 1 through 1, so that one character. It's going to convert it to an integer. That's what ichar does. It's going to subtract 32 from it, and then it's going to reconvert it back to a character and then put it in the return string. Now I'm going to show you what that 32 does in just a moment if you didn't see my functions video. Else, I'm just going to say return string of I to I is equal to the string of I to I. So the character is not between lowercase a to lowercase z. It's something else. It's a dash. It's an uppercase already. So why convert it if it's already there or if we don't need to use it? Now let's go ahead and save and build this. Make sure the syntax is correct, and it's not. Okay, I messed up here somewhere. Let's go to the very, so let's clear that and make it, and let's go to the very top. Okay, so what did I do wrong here? Statement occurred according to do or do else and do. I forgot my end else, or end if, sorry. All right, let's put that end if there. It's like forgetting your closing curly bracket, and it came out fine. All right, now, what is the 32 here? Now, if you didn't see my functions video, this is going to be new to you possibly. So what I'm going to do is I'm going to load up my browser, and I'm going to go to a web page called ASCII Table. An ASCII table, first of all, what is ASCII? ASCII is the numeric representation of characters inside of your computer. So ASCII is what now if you're on the mainframe, it's EBCDIC. But on workstations, PCs, it's ASCII or extended ASCII or Unicode. But for right now, we're not going to worry about Unicode. Unicode is the way to represent other languages like Mandarin, these really beautiful, like Korean, beautiful languages, more artistic-like languages. And so this right here shows that a lowercase a has an ASCII value of 97. You can see it right there, 97. Let me try to zoom in there. There we go. So lowercase a has a value of 97. What does uppercase a have? 65. What's the difference between those two? 32. So we want to convert a lowercase a to uppercase. We subtract from 97, 32, and we get 65. So that's, and by the way, that's how all computers are. Letters, strings are not stored that way. They're actually stored as their numeric representation because that's what a computer knows. It knows numbers. It doesn't know characters. It knows numbers. So that's what the 32 is. Now, what I'm going to do, since now we don't know if this is working yet. Okay, so let's not jump. I don't want to jump ahead of myself. What I was going to do is I was going to do a 2 lower. I was just going to go ahead and quickly do that, but let's not do that. Let's test the 2 upper first. Okay, so let's call it. So I'm going to go back up here before my contains, and I'm going to say the string equals Bill Sky. I'm going to say print the value of the string is the string, and now I'm going to say call to upper the string length, and I'm going to say print the uppercase value of the string is the string. Now I do want you to notice something here. I've actually modified the string. So I'm sending the string, and because the string is not listed as intent in, it's going to allow me to write to it. Now, so that should mean a couple of things to you. What you could do is you could say that the string is considered intent in, and how would you get the uppercase? You would have to have another string over here, like a return string, and let that return the value. So it depends upon what you want to do. If you expect that to upper is going to actually modify what you send it, then we're fine here. Okay, let's go ahead and make it, and let's run it. And something didn't work right. So the uppercase value of the string is it's still Bill Sky. So let's see what we did wrong here. I know what we did. I never reassigned the subroutine string to the string that was passed. So I'm going to say the string equals return string. And there's different ways of doing this. This isn't the only way to do it, but this is the way that we're doing it today. And now it works. So we know that's working. So let's do a 2 upper. And this is like totally simple. Or 2 lower. We're going to change this to 2 lower. And instead of lowercase a, we're going to say uppercase A, uppercase Z. And instead of minus 32, we're going to say plus 32. And we have to change this to lower. Okay, let's go ahead and call it. And let's print it. That's how simple that was. We got our first function working. Now we're going to go ahead and get our second function working. Oh, beautiful. I just love it. So it converted Bill Sky, all uppercase, to lowercase Bill Sky. I believe there's an intrinsic function, which is part of FORTRAN, which is already which is already there for you to use. So not an issue. Okay. Now, the next thing I want to do is I want to talk about how arguments set to a function are real values and not copies. So I'm showing you this. I want to demonstrate this whole idea of pass by reference. So what I'm going to do is I'm going to come down here and I'm going to say x equals 888, y equals 999. I said functions, I meant subroutines, but it's the same thing. Z equals 0, 0, 0. And what I'm going to say is, let's go ahead and print. I want to print ASCII, or I want to print an ASCII string and another ASCII string. Then I'm going to print three integer values. And if you don't know what I'm doing here on the print, take a look at my formatted output in FORTRAN, and you'll see what this is all about. So the values before print bars is okay. So again, if you're not familiar with what I'm doing here, what I'm doing is that I am specifying right here the format of how I want things to print, and then I'm specifying the data that I want to print. Okay, and I'm sure I forgot some commas or something, so let's take a quick look here. A35A, 3I, 5.3s. Oh, is that a 1 or an I? Let's make sure that's an I. 5.3s, comma 8. Okay, that's cool. The values is, there's my close, comma. Oh, I forgot to put a double quote right here. All right, let's take a look and see if that fixed it. All right, great. All right. Now, let's go ahead and now call a function which we haven't defined yet. And then let's copy this print and say after. Now this is really going to be a silly little function. So what I'm going to do is I'm going to put at the top of my, I'm going to put at the top of my contains just so we can see it. So let's put it up here. And I'm going to say, we can say recursive. I don't know, I'm not sure why I would do that. Okay, and I'm just going to do something very simple here. I'm going to go ahead and define these arguments as integers, and then I'm going to reset them. Let's make it beautiful. Let's run it. Okay, so we can see right here that the values before print vars is 888, 999, and 000. The values after print vars is 77, 88, and 99. So when you have a function like that that's sending by reference, and by default it's by reference, you may want to make absolutely sure that you want those variables to actually be modifiable. Now what you could do is you could say intent in, and that would make them constants within the function. So I could have said integer intent in, and I believe the compiler won't even let me get away with that. Oh, I put intent. I don't know why I keep putting that G there. Okay. There we go. And it says a W argument with intent in cannot be modified. So what we're doing here, we're actually creating these variables, and we're I shouldn't say creating them, we're actually copying them or sending them to the function by reference and not by value. And there is a way to set things up by, I can actually send them by value, but that just isn't done very often. So again, if you want to make them input only, if you only want to have them and you don't want the function to be able to change them, just say intent in, and then this problem goes away. You're not allowed to modify them. You could do something else. You could go ahead and modify a local variable and then have a fourth variable that actually has, like I can say arg4 here, and that's the return value. But let me show you now how to actually send this by pass by value instead of pass by reference, which is the default. So what I'm going to do is I'm going to copy my print vars function. I'm going to change the name to print vars2. And I went ahead and already deleted the arg4 from the other demo. And when I define what the data type is of those arguments, I'm going to say value, comma space value. So that means that those arguments can be sent by value. Now if I wanted to, I could do something like this. I could say integer arg3, and what that would mean is that arg1 and arg2 would be sent by value, arg3 would be sent by reference. But I don't want to do that. I want to send them all by value. And then what I'm going to do is I'm going to change the values back to some of these other values to 0. Let's go ahead and make this. Now I'm trying to show you how one function passed by value will not be allowed to change. I mean, the compiler lets you do it, but it actually doesn't happen. It just changes them within the function. So let's go ahead and copy the use of print vars. Let's change this to print vars2, and then let's call print vars2. Okay, so let's run this and let's talk about it. Okay, so as you can see here, well, that's not really a good, let's double check, make sure print vars2. So it came back as 888. So it didn't really print vars. Oh, I see what I did here. So I've got 888,999. So let's go ahead and change this to, I don't know, 112233. I must have made a change and did not reflect it. Okay, here we go. So when we first call print vars1, it's not really print vars1, it's print vars. Before we call it, it's 888, 999, and 000. Print vars changes those two arguments now to 11, 22, and 33. And when we come back from the function, those original values have now been changed to 11, 22, and 33. Before we call print vars2, we print that out again, and now it's validated. It's 11, 22, and 33. When we call print vars2, it changes it to 77, 88, and 00. But take a look at what output when we returned. It's still 11, 22, and 33. And the reason for that is because we put the comma value at the data definition of that subroutine. You can do the same thing on functions. I don't remember if I did that in the functions video, but I showed it here in the subroutine video. So again, by saying comma value, you're sending those values, or you're sending those arguments by value. It's a copy. And what I could do is, as I showed earlier, I could do arg3, and what we should see in this instance is arg3 is not actually modified. So it should, or actually will be modified, simply because we didn't have value there. So it's sent by reference. So you can split them up. And you can see right here, it did modify it because I moved 0 to arg3. So but the other two did not, because it said comma value. Very important distinction. All right, so that is an introduction to subroutines in FORTRAN, much the same as functions. Again, the important thing to remember is that a subroutine, they're older than functions, if I remember correctly, it doesn't matter, but subroutines are out there. They do not really return a value. You have to specify a value inside the argument list that you want to have that return. However, it doesn't just return a single value, it can return multiple values. That's one of the beauties of subroutines. So, We're going to continue this discussion of functions and subroutines in our next video. Hope to see you there.